Hey guys, so today we're going to be taking a look at what's called the rational zero theorem. So finding these things called rational zeros, and you're going to need your notes, a calculator, and something to write with, of course. So what happens when you're not given a factor hint like we were yesterday in the assignment? You had a hint that you could divide out to get this polynomial started so you could factor him and solve him to find all of his solutions. Well, what if we didn't have a hint? What if the directions just said to solve and we don't have any really big starting places or anything to go from? So what would we do then? That's our goal for today. Our goal for today is to find a way to solve polynomials that cannot just strictly be factored. So we need to be able to generate some sort of hint to get us started. So to find this hint, you need to become an educated guesser. I want you to write this part down. We're going to go ahead and start with what's called the rational zero theorem. This means that every rational zero, a rational number is a number that can be written in fraction form. Zero is a solution, another word for solution. So every solution to the polynomial can be written in this form or comes from this form. P over Q. Okay, P over Q. It seems like what? What's P? What's Q? What does this mean? Like, what is that? So here's basically what you need to know. The P represents the factors of the constant or the end number in the polynomial, and the Q represents the factors of the lead coefficient, the one in front. And by looking at those two numbers in our problem, we can use those to generate a list of possible clues for us to use to get the polynomial started, to start solving him. So to generate a list of hints, similar to what you had yesterday, to get that hint, to get it going, we can generate our own using this setup. Now, vocab flashback a little bit, in case some of these words are confusing you. Real numbers are numbers that really exist, okay? The other category, of course, is imaginary numbers, the ones with I in them. So real numbers versus imaginary numbers. Rational numbers are numbers that can be written in fraction form like a ratio. Irrational are numbers that cannot, like square root of 3, pi, those sorts of things. So these setups, or this theorem here, is going to help us generate the rational ones, so the ones that can be written in fraction form. That's why the fraction setup. So we're about to use this sort of setup to find the real zeros. So find the real solutions to this guy. This polynomial, is supposed to have 3 solutions. You can see that because of the cube there. And we don't have any hints to get this started. So at first you might say, hey, I'm going to go ahead and put these 4 terms in 4 boxes. Don't write this part down because this is not going to work. 2x to the third minus 5x squared minus 14x, 8. And if I go ahead and start taking things out here, 2x, 1, it looks good, but notice x squared times x, or even 2x here, if I could take a 2x out of those two, okay, that makes 2x to the third. This guy times this does not make 14x, negative 14x. So while it looks like this whole 4-term thing fits nicely into 4 boxes, the factoring that we are used to falls apart here. So I cannot use factoring to help us find our 3 solutions. So that's when we turn to this list. What we're going to do is look at the factors of the end and the beginning. So we're going to set up our P's and our Q's. Okay, P represents the number at the end. So what number's at the end? 8. So 8 is going to be my P, and then the Q, which is on the bottom of the fraction, represents the number at the beginning, 2. Now, we're not just supposed to put 8 over 2. We're supposed to find the factors of 8 and 2. So, ooh, that's not a good fraction line. So what are the numbers that multiply to make 8? Okay, so maybe 1 times 8 and 2 times 4. These are all numbers that are factors of 8. That means they can divide evenly into 8 or they multiply to make 8. Now remember, you can have positive numbers that multiply to make 8, a positive 8. You can also have negative numbers. Two negatives will multiply to make a positive 8. So in front of each of these, I'm going to put plus or minus because we could have negative 2 times negative 4, negative 1 times negative 8. Those are all ways that we can multiply to make 8. We do the same thing for the 2 on the bottom. 2, who are his factors? 1 times 2 makes 2, and that's pretty much it. So positive 1, negative 1, positive 2, negative 2. So the factors of 8 and 2 get written out in the P over Q sort of format. And then we go ahead and we simplify. This is what we do first. Then we go ahead and we simplify what we have written here to compile the list of possible rational zeros. So we're going to use this sort of setup to generate some numbers for us that are possible hints that we can use. So notice up here on the top, all of these numbers are supposed to be divided by 1. So we're going to do that first. 1 divided by 1 is still 1. 2 divided by 1 is still 2. 4 divided by 1 is still 4. And 8 divided by 1 is still 8. And of course, they could be positive 1 divided by negative 1. So again, we're going to put plus or minuses in front of all of these. Then after that, notice in our setup, we could have also divided by this 2 that was on the bottom. So we need to do that as well. What if we take 1 divided by 2? Well, that's a half. We don't have a half in our list yet, so we better put 1/2 is a possible solution for us. And then we need to continue. What about 2 divided by 2? Well, that's 1. That's already in the list right here, so we don't need to list it again. What about 4 divided by 2? Well, that's 2. That's still in my list here. And what about 8 divided by 2? That's 4, and that's already in my list here. So what we've done is generated a list of possible numbers. Positive 1, negative 1, positive 2, negative 2, positive 4, negative 4, positive 8, negative 8, positive 1/2, negative 1/2. All of these are possible hints that we can use to help us start solving this polynomial. So, continuing on. There's our polynomial again. And I've written out the list that we just generated. These are the numbers we just generated there. And we're going to use those to help us find the actual solutions. That doesn't mean they all are solutions, but somewhere in that list is a good hint for us to get this started. So here's my favorite part. We're going to go ahead and set up the division. Okay, the 2, the -5, the -14, and the 8. Okay, are from our polynomial there. And on the outside, we're going to put a possible 0. Okay, so a possible solution. Now, this is my favorite part because I have no idea which one out of those list of numbers there, which one works. Which one is the good hint, which ones are bad hints. So basically, you could look through that list and you guess. So maybe I'm going to guess maybe -1 because it's easy to multiply by -1. And I go ahead and I try to divide this. 2 drops down, -2, -7, 7, -7, 7, add 15. This right here is a remainder of 15. That means it doesn't divide out evenly, giving me a remainder of 0. That means -1 is not a good solution. It's not a good hint for us. So all of this, I guessed -1 and I was wrong. It didn't work. So now I have to look through my list and try to find somebody else who might work. Literally, you guess and you check until you find one that works. So I think I'm going to guess, let's just go -2. So I'm going to set up the division again. This time I'm guessing -2. Hopefully you're a good guesser because you might get one right away. Let's see, multiply, add, -9, multiply 18, add 4, multiply -8, woohoo! See that 0 remainder? I'm going to put a smiley face in that. That means that -2 is a good solution. Okay, he works. He was a good hint for us to get this started. Because when we divided that out, what was left here, if 0 is my remainder, this is a constant 4, this is negative 9x, oops, I'm going to put a negative in front of that, and this is 2x squared. By dividing out that solution, I left myself with this answer or this quotient, and now I can factor that to find the other two solutions to this polynomial, so I don't have to keep guessing through my list. So if I'm going to factor this, he's a trinomial, I'm going to do the AC method. 2 times 4 is 8. What multiplies to make 8 and adds to make negative 9? Negative 8, negative 1. I'm going to set them up in the 4 squares here to the side. So 2x squared, negative 8x, negative 1x, and 4. 2x, negative 1x, negative 4. So my two factors that come from this guy are 2x minus 1 and x minus 4. So if I was going to finish solving, who are the solutions to this polynomial? Where are the three solutions? Well, if I solve each of the factors here, I get a solution of 1/2, because I've solved this guy, put equals 0 behind it. Okay, and if I solve this guy, I get a solution of 4. And one more solution, don't forget the one we divided out right away that we found to work. Negative 2 was a solution as well. So we got our three solutions here. We had to do it by generating a list of possible hints, some of which do not work, and we found that out. Okay, so let's do one more example like this, and then we're done. So here's another polynomial. It has three solutions. Before we can get started here, we need to first figure out what are some possible hints that we can use to get this thing started. So p's over q's. Who's the p? The number in the back. Who's the q? The number in the front. We want all the factors of 9 and 2. So 9 is 1 times 9, 3 times 3, that's it. So plus or minus, plus or minus, plus or minus. And the factors of 2, 1 and 2. So using this, we can now generate a possible list of possible hints for us to use. So first we're going to divide everybody on top by 1. 1 divides by 1, you get 1. 3 divided by 1 is 3. 9 divided by 1 is 9. Okay, and then we're going to divide everybody on top by the 2. 1 divided by 2 is 1/2. 3 divided by 2 is 3/2. And 9 divided by 2 is 9/2. So I'm going to put plus or minus in front of all of these. This is the list of possible hints that we can use to get this thing started, essentially. So now we got to be a good guesser. So set up the division. 2x to the thirds, negative 7x squared, no x's, regular number. And now I just guess from my list. I have plus or minus 1, positive or negative 3, positive or negative 9, positive or negative 1/2, positive or negative 3/2, which is like 1.5, positive or negative 9/2, so 4.5. So I just guess, and I hope I'm a good guesser, because if I am, then I don't have to keep guessing. Last time I started with negative 1, it didn't work, but this time I have a good feeling. So I'm going to put negative 1 down there and try this thing out. So negative 2, add negative 9, multiply positive 9, add 9, multiply negative 9, 0, 0, 0. Good, this is a remainder of 0. That means my guess worked. This guy right here is a good solution. And by dividing him out, it leaves us with something that is factorable. So 9 is my regular number. This is my x's. So constant x's and 2x squared. So now taking a look at that, I can factor him to find my other two solutions. 2 times 9 is 18. What multiplies to make an 18 and adds to make negative 9? Negative 6, negative 3. So I'm going to go ahead and stick those in the 4 squares so I can get this thing factored. 2x squared minus 6x minus 3x, 9. 2x, negative 3, x, negative 3. Yep, that looks good. So my factors are x minus 3 and 2x minus 3. And if I solve each of those, this gives me a solution of x equals 3, x equals 3 over 2, and then one more solution because it was an x to the third. Remember who we divided out first to get this thing started? We found that he worked. We found that he was a solution because he gave us a remainder of 0. That means he's a 0, so he's a solution. Yay, we have our 3 solutions and we're done. So it's great when you guess right on the first time and it works. Not so fun when you have to keep guessing over and over until you find one that works, okay? So this is what we're going to be practicing, and we'll try to streamline your guesses a little bit more to be strategic about it in days to come. Okay, thank you for taking good notes, and I will see you.